All right. So on these quick notes, so we're just going to fill in kind of the things we just figured out on the other side. And the first one is that the domain of a function is the set of all possible inputs that produce a defined output. Basically, that's kind of a fancy way of saying if you put an x in, you get a y out. And like I said, until we start talking about logarithms, the only thing that's going to restrict our domain is a negative under a square root and a 0 in the denominator. So values that produce undefined outputs or errors like the square root of a negative or a number over 0 must be restricted. All right. And to describe the domain, it's up to you. You can use words if you want to. You can use inequalities or you can use intervals. So use words, inequalities, or intervals. To describe the domain. All right, now we're going to start off with the contextual problem. So contextual domain and range is a little different than just looking at a graph and telling the domain and range. So on number 1, a Ford Escape has a 14-gallon fuel tank and can travel approximately 26 miles on 1 gallon of gas. All right, so A tells us to write a function called D that gives the distance the escape can travel with X gallons of gas in the tank. Okay, so if X is the gallons of gas on the tank and we want to know how far it can drive, what would we multiply that by? 14 or 26? 26 miles per gallon times how many gallons? We'll use 14 in a minute. So that's the function that would give us this information. All right, let's talk about a reasonable domain and range. So domain, we're talking about gallons of gas because that's the X. So what's the smallest amount of gas you can have in your tank? 0. And for this Ford Escape, what is the most you can have? 14. Good. All right, range, we're talking about distance. Riders already kind of figured this out. What's the smallest distance you can drive? 0. For this Ford Escape, what is the largest distance you can travel on 1 gallon of gas or 1 tank of gas? Yes.
No. 364.
Y'all are about 30 seconds slower. That's okay. I appreciate your effort. All right. Now, let's say this wasn't a contextual problem and we just had this function. What kind of function is this? What's this graph going to look like? It's a straight line. It's a linear function with a really, that's not a very good line, a really steep slope. So if it wasn't contextual and you just wanted to find the domain and range of a line, what would they be? What's the domain of a line? Does a line have any restrictions? No restrictions, right? It's going to be all real numbers. So you can do all real numbers two ways. You can do this fancy R. Did your Algebra 2 teacher teach you the fancy R? You can do that. That means all real numbers. Did anybody's Algebra 2 teacher teach you how to do interval notation for all real numbers?
No. Yeah, I think.
Yes. So the smallest number in the domain is negative infinity and the biggest is infinity.
Yeah.
Either one is fine with me. It's up to you. Don't do ARN. I think there might be like a middle school teacher that teaches you that. Don't do that. Do the symbol or the interval notation. All right. So let's look at number 2. We can look at the graph if you want to for this. But if you wanted to find the domain just by looking at F, what do we have to watch out for? 0 in the denominator. So there's 2 things you have to watch out for. 0 in the denominator, negative under a square root. This one we worry about 0 in the denominator. So what can x not be? Yep. So all you have to do is just say x is not equal, do a little slash, not equal to negative 7. Now the range, until you learn about these functions and the horizontal asymptotes, we probably really can't do that. So I'll just type it in real quick. All right. So here's the graph. Why do you think it does this line right here? And -7. That's -7. That's because that would give you 0 in the denominator. So that's the vertical asymptote. So what does it look like the y is getting closer and closer to, but not quite getting to 0? Yeah. So the range is just y does not equal 0. Okay, I'm trying to remember exactly what this one looks like. I think it looks maybe like this. Definitely has an arrow going up and an arrow going down for G. So if you have an arrow pointing to the left and you have an arrow pointing to the right, what do you think that means for your domain? It's all real numbers. So you can do fancy R or you can do negative infinity to infinity. All right. If you have an arrow going down and you have an arrow going up, what do you think that means for the range? All real numbers. So a lot of functions don't have any restrictions. You're just looking for that denominator or the root. All right, so on number 3, it's just asking for the domain. So G looks a lot like what we had on the front with the semicircle, but what do you think the radius is? If that's a 16 under there, what do you think the radius is? Yeah. Now we could look at this in the calculator. I'm just trying to save a little bit of time. And it's good to just think instead of looking at your calculator. All right, so if I drew that perfectly, it would be a semicircle. What would you guys say the domain is? What's the smallest number in the domain? Yeah. And would we use brackets?
Yeah.
Because 4 and -4 are fine because you can take the square root of 0. That's fine. All right, this other one, this is -4 and this is 4. It looks like that.
Wow. What are you showing us? Grass.
We can pull it up. I was just trying to save time. Do you guys trust me? That's what they look like. It's going to keep going this way, and it's going to keep going this way. All right, so H for the domain. So what's the smallest number in the domain? -infinity. And we're going to go from -infinity all the way to -4. And we are going to include -4 because, again, square root of 0 is fine. All right, and I don't know if you guys have seen this before. If you have two interval notations and they're both answers, they're both part of your answer, you do this U in between. It stands for union. Have you guys seen that before? Okay. It just means and, basically. And then what are we going to pick back up at? Bracket 4 to? Good job. All right, and then this last question, we have a piecewise function, and I'm not 100% sure how much you guys learned about piecewise functions, but one of these pieces is part of a parabola, and one of these pieces is part of a line. And it's just one function, though. Okay, I'm going to zoom in. Hopefully it won't disappear. So what is the first x value where something is graphed-ish? -4. Now, I don't know if you can tell, but that's a hole there. It's not an actual point there.
So I mean, it's a print.
Very good. Okay, so we start at -4, and then we have it graph, solid circle. It picks back up here and graph. So what do you think it goes to? Infinity. Good job. Do we put brackets on infinity?
But it's an open so no.
We never put brackets on infinity. All right, the range is a little trickier. So what's the smallest y value where you have something graphed? 0. And to me, it looks like it actually touches 0. So we're going to do a bracket on that. All right, so we have something at 0, and then we're going up. And then where does it stop existing?
9.
At 9, yep. And that is a solid circle there at 9, so we're going to do a bracket. All right, and then we're going to do our U for union. And then not 9. 12.
But it's not included.
Exactly. Good job. You guys are so good at domain and range.